Welcome back. In this set of videos, we are going to be looking at rate of change and slope. In this video, we'll be looking at rate of change. Rate of change is a ratio that compares how much one quantity changes on average relative to the change in another quantity. We can express this in symbols or in math terms as the rate of change is the change in y over the change in x, or delta y over delta x. This triangle we read as delta, it's a Greek letter, and it means change in. So this is the change in one variable with respect to another. The y variable will be our dependent variable and the x variable will be our independent variable. So when we're looking at rate of change, here's an example. The table shows the temperature of a solution after it has been removed from a heat source. Find the rate of change in temperature for the solution. This temperature is changing at a constant rate. So we are going to be looking to set up this formula, the change in y over the change in x. In this case, temperature will be our y and time in minutes will be our x. So I'm going to look for the change in y over the change in x. So it's important that I am going to keep consistent. So I'm going to do over the first time period. So I'm going to use the ordered pairs 0, 143.6 and 2, 139.4. So change in y will be the final temperature was 139.4 minus the initial temperature of 143.6 divided by the final time of 2 minutes minus the initial time of 0 minutes. 139.4 minus 143.6 is negative 4.2 divided by 2 is negative 2.1 degrees Celsius per minute. So the temperature is changing at a rate of negative 2.1 degrees Celsius per minute. Or the temperature is decreasing at the rate of 2.1 degrees Celsius per minute. So this is a case of average change where the change is constant. So if I had done this change between the times of 8 minutes and 12 minutes, I would have gotten the same answer. In the next example, we have two different relationships that are graphed on the same space. The graph shows the number of digital and film cameras sold by a store in recent years. Find the average rate of change of the number of digital cameras sold from 2004 to 2009. The word average is an important word in this problem because it means I'm not looking at the change for each year individually, but rather the total change. So I'm looking at the final versus the initial. So my final in 2009, which I'm just going to express with a 9 for 2009. In 2009, they sold about 75,000 cameras. And the initial, in 2004, they sold about 20,000 digital cameras. So my average rate of change is going to be my final number of cameras sold, 75,000, minus my initial, which is 20,000, divided by the final year, which is 2009, minus the initial year, which is 2004. My ordered pairs should be stacked. So this is 55 over 5, or the average rate of change is going to be 11,000 units per year. And this is going to be a positive value. So that means that on average 11,000 units per year more were sold. Find the average rate of change for the number of film cameras sold from 2004 to 2009. Same thing, the final amount in 2009 is about 25,000, and the initial in 2004 is about 60,000. So to set this up, I will do my final, which is 25,000, minus my initial, which is 60,000, divided by my final year minus my initial year. So this is minus 35 over 5, or the average rate of change from 2004 to 2009 is about negative 7,000 units per year. You'll notice that in A, this is positive, and in B, this is negative. A positive rate of change is going to indicate an increase over that time, and a negative is going to indicate a decrease. You'll also note that it relates to my graph in that digital had a positive rate of change and my graph goes up to the right, and film cameras have a negative rate of change. My graph goes down to the left. The negative means that they're selling fewer cameras each year, positive that they're selling more. One last example for rate of change. In 2004, 43,201 students applied to UCLA. In 2006, 47,317 students applied. In 2008, 55,441 students applied. Find the rate of change for the number of applicants from 2004 to 2006 and 2006 to 2008. I'm going to convert all of these into ordered pairs. So in 2004, which I'm going to indicate with just a 4, 43,201 students applied. In 2006, 47,317. And in 2008, 55,441 students applied. So from 2004 to 2006, our average rate of change is going to be the change in Y, so that'll be 47,317 minus 43,201 divided by 6 minus 4. That works out to be 4,116 divided by 2, where they gained on average 2,058 students per year from 2004 to 2008, or from 2004 to 2006. From 2006 to 2008, in 2008 they had 55,441 students, and in 2006, or applications, and in 2006 they had 47,317 applications, divided by 2008 minus 2006. So in those 2 years, they had 8,124 additional applications, which is positive 4,062 students per year, or really applications per year. So they had an additional 4,062 students apply to this school per year between 2006 and 2008.